Hello, welcome back to the channel. This is the basics of Diag, and today we are looking at a 2012 Vauxhall Astra 2.0 CDTi. That is a no crank. So without further ado, let's get into it. We need to first actually experience the fault. So there we are. That was probably the easiest fault I've ever had to confirm. It does not crank when turning the key. I could hear, sort of in the glove box area, some relays clicking. So I'm assuming the ignition switch is okay. First thing I'm going to do is use this little Think Diag Mini just to get any codes, see if we can see any data that might help us, like key position, start signal, if there is anything available. So let's get connected. We're in Vauxhall. I'm going to do an automatic search, and it has found Astra J 2013 with the A20DTH engine. I'm going to do a health report, and that's going to interrogate all the modules and pull any codes from the modules. Yeah, just the ECM, so let's have a look. Starter relay control circuit. Immobilizer key incorrect. Okay, so I'm going to clear these codes and then see if I can recreate the fault again. Oh, hang on. So that code hasn't actually cleared. Clear fault. Successfully cleared. Read code. Yeah, will not clear. So it looks like we're going to be heading towards the starter relay. So we're going to have to get some information on where that is located. I just want to have a quick look in maybe the BCM. If there's a steering column module maybe in there. I just want to see if we can see the key position, see if it's registering that it's in the crank position. Because this we could be going from this key through a steering column module. That could be sending a signal to a body control module, which could then be sending a signal to the engine control module, which is then grounding the relay or powering the relay. So I just want to see if all the signals from this key are getting to where they need to be. That is if this tool can show me that. So I'm going to have a quick look now, and if I see anything, I will show you. Right, so I've found something. This is in body control module. Let's go back. Yeah, so body control module, data stream, ignition on, and then we're down to power mode data. And then I've just gone select all, but it's like the top 5 or 6. So this is ignition off. So you can see everything's inactive, key is out. This is position 1, is it? No, that's position 1. You can see the second one down. Accessory goes to active. Position 2, ignition switch is in run. And the fourth one down, auxiliary ignition run relay goes to active. And then if I go to crank it, you can see the top one, crank request, goes to present. Obviously all the others change. So that is enough for me to say that the key, the ignition switch, the wiring up to the body control module is all good. So I think we're going to be going to that starter relay. I want to know first, is the starter motor operational? So I'm just probably going to switch or bridge the relay just using a piece of wire. And if it cranks, then yeah, that is a quick test that rules out starter motor, trigger wire, power to the relay for the load side. So yeah, we will do that now. But first, let's have a look at wiring diagram. Okay, so this is our wiring diagram. I've just used the Garmin app to get this, and I've just taken a screenshot. But you can see center screen there is our starter relay. We can see the consumer side or the load side on the left with the switch. It has a permanent power supply from, well, a 250 amp fuse right at the top. Then that comes into the under bonnet fuse box into a 30 amp fuse. And that switch obviously goes down to the starter motor solenoid, the trigger wire on the solenoid. So that's going to be the circuit that I bridge with my piece of wire. And the control circuit is what the fault code was listed for. So that's the circuit on the right with the coil, that when that coil is supplied a power and a ground, it creates an electromagnet. You can kind of see it in this diagram, the dotted line, and then it attracts the switch closed. So if we follow the terminal 86, the bottom wire, that comes out, turns into a dotted line, comes along and goes to a ground point. So that should be a permanent ground, pin 86. And pin 85 is, it's got to be a power, hasn't it? Where does it come from? Engine control module at the top there, K20. And then our wire is, obviously there's a switch, which at the top is probably a transistor. Comes down into, I don't know what these diamond boxes are. But yeah, it can only be a power supply. If pin 86 is a permanent ground, for this coil to turn into a permanent, to an electromagnet, it's got to have a switched power supply. So yeah, let's get a piece of wire, and then we're going to bridge terminal 30 with terminal 87. If all is well, the starter motor should spin. Right, so this is our starter relay, and we can see pins 85, 86, 87 and 30. Normally I would use a piece of wire like this to bridge it, but as you can see, this is a lot thinner than I was expecting, so we're going to have to use back probes and the wire, a lead. Oh no. Oh no. So pin 30 was here. Pin 87 here, and with any luck crank. Oh no, it's fallen out again. Oh god, these aren't the best fitting back probes I've ever used. So the engine cranked, and if... Oh hello, what is that? What is this guy? Freaky looking. Yes, so if we had a checklist, well, we have got a checklist of things we need to check. There's 4 things on it. There is power supply from the fuse, which is obviously good because it's turned the starter motor. There is obviously a ground path on the other side of the switch when the switch closes. I say a ground path. It's ground until that solenoid is energized, and then it isn't. But yeah, so the wire from the relay to the starter motor is good because the starter turns. So that's 2 things crossed off the checklist in one test. We now need to check that we're getting, there must be a switched power supply when this ignition is turned on, or when the key is cranked, in fact. So I've got a test light I'm just going to use to to check that. And we've got the permanent ground for the other side of the control circuit, the coil side of the relay. So let's get this test light set up, and we'll do the next test. So this pin we know is good, and this top right and bottom left we know are good. So we're gonna look for a switched power supply now. So we've got our test light on ground. When we touch battery positive, it'll light up. So I'm going to try and rest it in here. Hopefully we get a good connection. I might put a back probe in actually. Put a back probe in. Rest it in a back probe. Hopefully I can see this from the car. Yeah. Key in. Crank. There we are, did you see that? Crank. Bulb lights. Again. So that is our switched power supply from the ECU. You probably just want to be careful with the test light that you use. I think this 501 bulb draws about 300 milliamps. If you're using something that draws a bit more than that, you may want to be careful. You don't want to blow anything inside the ECU, the transistor. I'm not sure what sort of current it will handle. I know the coil side of a relay, they don't usually go above 200 milliamps, 250 milliamps. So yeah, maybe just use an LED test light. It won't load the circuit, but it'll give you enough information as to whether that ECU is controlling the wire or not, controlling the relay, and then you may need to load the circuit in a different way. Right, one test remaining, and that is this permanent ground. So let's, again with the test light, so have a look. This clamp to a positive, and then when we probe a negative, we light up, and it should be this pin 86, and we get nothing. Test the tool, lights up in here, nothing. And that's funny because we've got some markings on here and it's like the ones that have been marked to the ones that are checked out okay, which is it's funny, that, isn't it? So how can we prove this then? We need to give this a ground and see if anything changes. I'll tell you what, I've impressed myself with this one. Right, what we've got is a T-pin hooked over this, or what should be this ground, for this relay. That just pushed in, and then just a crocodile clip on the battery negative, and just a short lead. Let's crank it. Come on. Ooh. Yes. So there we are then. This Astra is missing a ground to the starter relay. It's not fixed, I'm going to show right now. If I do end up fixing this, I'll show you where the break is, what's broken, possibly, but I'm not promising anything. Okay, I've just taken some time off camera to remove the fuse box. And if we look at the wiring diagram, we can see that this pin 86, which is our ground, I don't know if you'll see that, for this starter relay, is on connector X3, and it's pin 21. Now these fuse boxes are actually quite nicely labelled. The connector numbers are quite nicely labelled, so I'm going to commend Vauxhall for that. See, this one is X2, this connector on this bolt, which is the big one on this side. Oh, they're numbered on this side as well, look, easy. So yeah, X2 is this connector, X1 is this connector, X3 is this connector, and pin 21 is right here, look. So we need to find that corresponding pin on the vehicle side, on the wiring loom side of the car. I'm just going to use my test light again, so connect this up to battery positive, and then we're probing for a ground with this tip. If it lights up, we know the ground is good and this fuse box is the problem. If it doesn't light up, the wiring is bad, or wherever it grounds to is bad. Chassis, I don't know where it grounds to at the minute, is bad. So we need to do that test now, and that is going to conclude this video and the fault on this car. Right, power probe test light is hooked up. We need to do a little bit of backwards thinking on this. So 21 is there, and then when that folds over, it's going to be this pin here, and we have light. And that test proves that the fuse box is at fault, and I've already gone ahead and ordered a second-hand one off eBay. This is off a 2014 Astra 2.0CDTi. All I did was match up the part numbers on here, wherever they are, this bottom corner. One thing I'm going to do is I'm going to swap all the fuses and all the relays out of the original fuse box, because I know, apart from that ground issue in here, that everything else is working fine. I don't want to end up with a potential other fault because a fuse is blown or a relay is no good. And then obviously I'm hoping that this fuse box isn't an issue as well. So I'm going to do that, and then hopefully we'll be cranking the car without that lead hooked up. Right, fuse box is in. I've got no earth lead on this battery or on this relay. Let's give it a go. Ooh. And that is what I'm talking about. Oh, we need to do sort of window reinitialization. It's just telling me to do that. Open driver's window, then close it. Oh, there we are, the auto up and the auto down. Now I'll do the passenger window. Then up. Now the auto feature works. Lovely. Right then, that's this video done. And yeah, an earth inside the fuse box was faulty. I don't know whether to open that fuse box up, see if I can see anything. There's probably just a track on a circuit board that's failed, you know. So yeah, thanks for watching, and we'll see you next time.